Hello, I'm John McManus. I'm with Concept Life Sciences. So this week Concept Life Sciences has been attending SOT, one of our main toxicology conferences for the year. It's been really exciting, it's been really interesting. We've had lots of good meetings with known friends and colleagues, and also with lots of new clients who've been attending the stand as well. Key things we're really focusing on this year are a lot of the additional supports and the continuation of the mechanistic work that we have a long history of supporting, and then also a lot of the newer endocrine disruption aspects that we are bringing in, both in a screening and also as a regulatory submission aspect. We're seeing a lot of interest in that from a lot of clients. So we hope that the conference will continue in a very successful vein as it has done so far, and we look forward to talking to our clients about these areas in the future. Thank you.
So you'd like me to explain the poster?
Yes.
So our poster here is a suite of assays that we have set up to screen for mechanistic endpoints in vitro that are important for thyroid hormone homeostasis. And so on the first panel here we have recombinant human and rat deiodinase activity. Deiodination is important because at the site of thyroid hormone function, you need to remove an iodine to make the active T3 hormone. And so we've expressed these proteins in HEC293 cells and shown that they have activity and that they can be inhibited by reference compounds. So PTU, polythyrouracil, inhibits human and rat deiodinase 1. It doesn't inhibit 2 or 3, but gold thioglucose will inhibit 2 and 3. And so we have shown that we have an assay in place that can be used to screen compounds for inhibition of deiodinases. And this can be done to GLP or not to GLP, depending on what people want. And it's robust and it's reproducible. And it's, to my knowledge, the first recombinant protein assay. These proteins are difficult to make because they have an absolute requirement for selenocysteine in the active site. And so we've managed to get the ectopic system to express them correctly. So that's been very useful. Another important enzyme in thyroid hormone homeostasis is thyroid peroxidase. Thyroid peroxidase is responsible for oxidizing iodide in the thyroid, which then allows it to chemically combine with tyrosine. And so we have, using human, rat, dog and pig microsomes made from thyroids, measured the activity, did the kinetics to sort out the activity of the assay, and then measured the inhibition of these of the protein in these species, using again PTU, which is a reference inhibitor for these. And we can just use this assay now to screen compounds in the various different species for their ability to inhibit TPO. And of course, if you don't inhibit it, you don't have the problem. Moving on then, looking at comparative metabolism, there are a number of different assays that are available to measure thyroid hormone metabolism, but the sensitivity of them wasn't great. So we developed an MSMS assay using authentic standards to sensitively measure thyroid hormone glucuronidation in the culture medium from cells that are that are cultured in 2D. We spike the thyroid hormone into the culture medium at the end of the period where the cells are exposed to their inducers, and we simply collect the medium and measure thyroid hormone concentrations in the medium, and we can show that the assay is also now being used in our ex vivo microsomal. So this panel here is microsomes prepared from rats that have been controlled diet. 3MC is with an enzyme assay, an enzyme inducer, and PCN, and we can see that our analytical method improves greatly the sensitivity that we can see in our ex vivo screen, which we regularly do. But also, it's sensitive enough that when we take primary hepatocytes and culture them for either 72 or 96 hours in the presence of a cocktail of enzyme inducers, And we needed a cocktail of enzyme inducers because unless we have a pan induction of the UGTs, we're not getting enough of a robust or sensitive response. And we can see that we can induce metabolism in cultures of rat hepatocytes. Importantly, equivalent expression in human hepatocytes is very low. And we've been unable at this point to induce the metabolism of T4 in 2D cultures of human hepatocytes. And so the big question out of that was, are they simply not being able to be induced? And so to test that, we compared the messenger RNA expression of a number of UGTs that are involved in metabolizing thyroid hormone, and we just wanted to see if our cocktail would induce the expression of the messenger RNA for these enzymes. And a number of them are being induced. UGT 1A8, 1A9, 1A10, 2B4 and 2B7 are being induced in human hepatocytes. So we know that the system can be modulated by our reference compounds, but from an activity point of view, we've just not been able to detect those changes. In rats, we can detect the changes in activity, and we can see the corresponding induction of the messenger RNA for the enzymes that we know to be metabolizing thyroxine in rats. And so this has been useful because we can see that there is somewhat a higher basal level of a number of these proteins when you compare it to the human proteins, because we're looking at we can do, if we look at this marker here, this 2 minus delta CT, it's a measure, it's not a relative measure, it's the same axes that's used across both graphs. And so while this is not a perfect system just yet, we have started to culture our cells in 3D, and the spheroids that we have been making, we hope to be able to apply to these systems and see if we can get a better, more robust response. Other things that we've been doing that are not reported here, we have started to set up sodium iodide symport, and that's another important protein in thyroid hormone homeostasis because it's responsible for taking iodide from the plasma and bringing it into the thyroid, where it is then used to make thyroid hormone. And that assay should be up and running in about 6 or 8 weeks. That's it.